All right, for our next part of our study guide, we are looking at the predicting products. So this is for questions 6 through 12 on your study guide. And we want to predict the products, we want to balance the equation, tell the type of reaction, and give our symbols. And if there's no reaction, we're going to write NR. Okay, so our first one we're starting with C5H12, and we are combining that with oxygen. Okay, now if we take a look at this, we are going to notice that we have a hydrocarbon and we have an oxygen. So that tells me that I'm going to have a combustion reaction, which combustion reactions are going to give us carbon dioxide and water. Okay, oops, can't see that, sorry. All right, so when we look at this, let's take a look at our balancing because we've written our combustion reaction out. So I'm just going to put C here for combustion. We have 5 carbon, 1 carbon. I'm going to make it a 5. We have 12 hydrogen, only 2. I put a 6. This gives me 10 oxygen plus 6. That's 16 oxygen. 8 gives me 16. So 5 carbon, 5 carbon. 12 hydrogen, 12 hydrogen. 5 times 2 is 10, plus 6 is 16. 8 times 2 is 16. We said this was combustion. On this one, I'm not too concerned about us putting in the solid liquids or gases. I would probably give you something because the hydrocarbons we haven't really learned very much yet. Okay? Alright, so problem number 7. We had nitrogen, which is a gas, it's a diatom, combined with hydrogen, which is going to be a gas. Okay, same thing on this one. It's not too big of a deal for us to worry about these gas ones because they're a little bit different. We haven't talked about them totally. Okay, so if I take a look at this and how it would come together, this to me is a synthesis reaction because I have 2 individuals that are going to have to come together as one. This one's a little bit trickier to figure out. If we look at nitrogen, we know it has 5 valence electrons. It means it's going to take 3. That means I'm going to end up with 3 hydrogen. Okay, so I'm going to get NH3, or good old ammonia. Alright, so now let's take a look. We had 2 nitrogen, 1, let's make it a 2. That now gives me 6 hydrogen. Here, 3 gets me to 6. I have 2 things coming together. This is a synthesis reaction, or I'm just putting an S. Question 8. We have aluminum, and it's solid, plus zinc chloride, which we said was aqueous. Alright, the first order of business is this is a single replacement reaction. You can tell by 1 thing here and 2 here. We have to look at our reactivity series. We have to look and see if this reaction is able to take place. So, I've got a picture here on my other phone of the reactivity series. I don't know if you guys can see that very well or not. What we're looking for is we're looking for aluminum to be able to replace zinc. Aluminum is above, it can replace below, so that means this can actually take place. Aluminum can kick zinc out. Okay, so to do that, aluminum's a positive 3, chlorine's a negative 1. So this side is going to end up AlCl3 plus Zn. Alright, so this is how we get the second part of this. Now, in this case, zinc's going to be a solid, this is going to be our aqueous. Now, when we balance, we're going to start with the aluminum, so 1 here, 1 here. 1 Zn, 1 Zn. Now we've got 2 chlorine and 3, so closest thing in common, get it to 6. Make that a 3, make that a 2. That gives me 2 aluminum, fix that, 3 zinc, fix that. My coefficients are 2, 3, 2, 3, and this is a cation single replacement or displacement. So I just put SD or SR. Alright, next question, number 10. We have bromine, which is normal state liquid. Okay, that's what this means. And we're going to combine that with KCl, potassium chloride, in aqueous solution. I take a look at it, to me it looks like it's going to be a single replacement reaction again. So I want to check and see if this can take place. Now this time, bromine wants to kick out chlorine. So we're going to go to my same picture, get logged into my phone here. Okay, and we're going to come over and look here. Alright, so what's trying to happen is bromine's trying to kick out chlorine. Can't do it. Can fall down, can't fall up. This isn't going to happen. This is no reaction. Next problem, number 11. We have HGO. Alright, HGO, we look at it, I only have one reactant. To me, this is going to break down. It's going to be decomposition because I only have one reactant. Two things that make up HGO are mercury and oxygen. Oxygen's a diatom, don't forget that. Alright, so we would put the 2 there. Okay, when we take a look at this then, to balance, we have 1Hg, 1Hg, 2O, 1O, make that a 2, make this guy a 2. There's my balanced reaction for my decomposition reaction. Okay, and my next one, number 12, I have aluminum plus mercury acetate or acetate. Okay, same thing. I'm looking for a single replacement reaction here because I can see that this is going to have to kick somebody out. So I'm looking to see if aluminum is going to be able to replace mercury. So let's come over here. Here's aluminum. Alright, do we have mercury? It's clear down here at the bottom, so yes, aluminum can definitely kick him out. Alright, so aluminum's a 3 positive, and the acetate is a negative 1. So on this side, I'm going to get AlC2 H3O2 3 plus mercury. Okay,